The Rayleigh number is a dimensionless quantity in fluid mechanics that quantifies the ratio of inertial forces to viscous forces within a fluid flow, predicting whether the flow will be laminar or turbulent. Low Rayleigh number indicate laminar flow, which is smooth and ordered layers, while high numbers signify turbulent flow, which is chaotic and swirling vortices, with an intermediate transitional range in between. The number is calculated using fluid density, velocity, a characteristic length like pipe diameter, and viscosity.
Given question number 20, determine the type of flow if a fluid of viscosity 0.155 times 10 to the power of negative 4 Newton second per meter square and a density of 850 kg per meter cube. The pipe 28 mm with a discharge of 0.135 meter cube per second. So what does this question ask for? The objective of this question is to determine the type of flow for a fluid moving through a pipe, which means we need to find the Reynolds number to determine the type of flow.
So how do we solve this question?
Step 1. We need to gather information from the question and select the suitable formula. From the question, we can see that the given density is 850 kg per meter cubic and the dynamic viscosity is 0.15 times 10 with the power of negative 4 Newton second per meter. The flow rate given is 0.135 meter cubic per second and the diameter is 28 millimeters. The formula that we will be using to find the Reynolds number is either density multiplied by flow rate and diameter over dynamic viscosity or flow rate multiplied by diameter over kinematic viscosity. Step 2. We must ensure all units are in SI units. If it's not, we must convert it. Since the diameter given is in millimeter, we must convert it to meters by dividing it with 1000. And now the diameter is 0.028 meters.
The third step is to choose a formula and find the missing information. According to the question, we decided to use the Reynolds numbers equals to density times velocity and diameter divided by dynamic viscosity. Looking through the formula, we already had the value of density, diameter, and dynamic viscosity, which means we need to find the value of velocity. Since we were given the value of discharge, we can find the value of velocity using the formula of discharge equals to area times velocity. But before that, we need to find the area using the formula of pi times d squared divided by 4. We then get the value of area, which is 6.158 times 10 power negative 4 meters squared. After that, we insert the value of area in the discharge formula to find the value of velocity, where we then get 2.192 times 10 power 2 meter per second. After obtaining the velocity value, we can finally solve the question using the post formula. We will get the Reynolds number equals to 3.366 times 10 power 8, which is greater than 4000.
How to determine the type of flow?
Moving to our last step, it is to compare the critical Reynolds number. As you can see from the table, if the Reynolds number is less than 2000, the flow is considered laminar, meaning it is smooth and orderly. If it's between 2000 and 4000, we call it a transition flow, where it is start to become unstable. And if it is greater than 4000, the flow is turbulent, which means it is chaotic and full of mixing. Since our calculated Reynolds number is 3.366 times 10 to the power of 8, which is greater than 4000, we can conclude that the type of flow for this question is turbulence.
In conclusion, by using the given information and calculating the Reynolds number, we have determined the fluid flow in the pipe is turbulence. Thank you.